Bismillahirrahmanirrahim. Welcome back to my channel. I'm going off the topic. Normally, I make videos about communication systems and RF systems, which is actually my basic field. But I'm just going out of topic, and I'm going to start making a tutorial on this system, which is actually a LabVolt system, which is a complete electromechanical system, where you can do practical analysis on motors, different type of motors, transmission systems, electrical distribution systems, and things like that. This trainer that I have is actually known as LabVolt series, and this is LabVolt series. It has a model number 8821.2.25. It is actually a modular system where you have different type of systems, like for example regulating auto transformers. Different type of meters are there. You have different type of loads, resistive load. You have a three-phase transmission line model. You have transmission three-phase transmission line. So these are interchangeable. These modules that you see, you can just simply take them out and insert a different one. Like for example, you can do experiment on DC motors. You can do on AC motors, and there are different modules which actually comes with it. So today, basically, what I'm going to do, I'm going to introduce you to each. So the series of these lectures are going to be introduction to each of these modules and what kind of practical and what kind of a demonstration you can do using a LabVolt system like this, which looks something like this. This is a very good system. I also have an older model as well, which I've been using, but this is a newer version. So basically, I'm going to start off with introducing you with a power supply, which is the basis of these modules. That power supply is actually this, which actually consists of. So I'm going to turn on this power supply. So this power supply actually consists of three phase constant, three phase variable. You have DC constant, and you have DC variable, and you have DC constant. Just to introduce you about this power supply. So this system is based on European and Asian system. So here the frequency is around 60 hertz, 50 hertz. Excuse me, it's not 60 hertz. It's actually 50 hertz, and the maximum voltage you can get out of this from these three phases, 1, 2, 3 points, and a neutral is 380 volt, and you can get 220 slash 380. So from line to line phases, you will get 380 volts, and from line to neutral, you will get 220 volts. So this is for variable. This is for fixed. Sorry, this is for fixed, and this side is for variable. So from line to line phases, from 4 to 5 or 5 to 6 or 4 to 6, you will get variable voltage of 380 volts, and you can change this using this knob. The numbers that you see is actually 10, 20, 30, 40, 50, 60, 70, 80, 90 is actually telling you the percentage. So for example, if you have your voltage variable from line to line, so you will get, if you have your knob set to, let's say, 40, so you will get 40% of 380. All right, in a variable configuration. That's what it means, that you will be able to change this. And from line to neutral, you will get exactly 380 volts. Normally in South Asian countries, normally this is 440. The three-phase voltage that you will get from your transformers is actually 440, but here it's rated for 380 for demonstration purposes. And the line voltage which is coming out from your wall socket is around 220, but in North America it's normally around 110 volts and a frequency of 60 hertz. Same thing here. I also have this in terms of DC. So both of these knobs are DC variable, and this is DC fixed. The maximum voltage you can get is from 0 to 220 volts DC with 5 amperes of current, which is variable. You can change it with using this knob, and here you will get fixed voltage. So I hope you're understanding what I'm trying to say in this LabVolt. All right, so let's try to learn individual component. Let's try to see how does these individual component and how to make connections to operate this. For this purpose, I have my multimeter, which is right here, which is connected. There are some other things about this too. You can use a built-in voltmeter, and here you can change the selector to see what type of a voltage coming out from each of these, from, let's say, from 5 to 6. So from 5 to 6 you will see a voltage display here, but I have actually connected an external multimeter. Here also you have different type of breakers. So for example, if more voltage comes in, these breakers will trip. Also, these two outputs that you see, these are just to connect these analog meters via this using a cable. You can also do this, but we don't need it since we have a digital multimeter here. Okay, so let me try to introduce this power supply. So as I told you, this is the fixed part, this is the variable part, this is the fixed variable part for DC, and this is the fixed part for DC as well. So what I'm gonna do, I just have simply my voltmeter right here, which is connected. I'm gonna put this on DC, and I'm gonna look at the voltage which is coming out from each of these points. So the first thing I'm gonna do, I'm gonna take my positive side, I'm gonna insert it here. This is the variable part, and I'm gonna take my negative side, I'm gonna insert it here. So now the next step I'm gonna do, I'm gonna turn this on. This is my multimeter which is turned on, and I'm gonna move this knob. Okay, now the next thing that I want to do, so right now as you can see there's no voltage which is coming out, which is a DC voltage. Now the next step I'm going to do is actually increase this voltage gradually. So this as I explained on this knob, that these are percentages, so 50, 60, 70, 80. So whatever the rated voltage is, based on this knob you will get that percentage of that voltage. So for example, right now it's supposed to give you 220 volts DC. When I have it this knob on 50%, let me just move this to 50%, I would get about 134 volts. All right, so let's look at the maximum DC that is coming out. Even though it says 220, let's just do 100%. At 100% I'm getting 267 volts DC. Why am I getting 267 volts? Because to compensate if there's a load connected, so you will get a steady 220 volts. That's why you're getting more voltage here. But once you connect a load to it, you will get around, so it will actually maintain that 220 volts barrier that you're supposed to get. So at 100% I'm getting about 267 volts. Now this is the variable part. All right, so let's just turn this knob off, and I'm going to show you the fixed part. So right now you're not seeing anything. Once I change this probes, let me take out this probes and let this put on neutral, and this is right here, and look what I'm getting. So without even touching the knob, my knob is all the way down, my knob is all the way at 0. At fixed I'm getting 260 volts, exactly the same thing. Why am I getting 260 volts instead of 220? Because there's no load connected. If I connect the load, it should maintain that 220 volts. So that's the idea behind DC. So this is for DC variable, this is DC fixed. Now let's go over here and let's try to see three-phase voltages. So let me just simply remove this, and I'm going to change the setting on my multimeter. I'm going to change this to be AC voltage right here at 600 volts, because the maximum that you can get out is about 380 volts. All right, so I'm just going to simply, I'm going to go from 4 to 5. I want to see line to line voltage, means line to phase voltage between the phases. So right now I'm not seeing anything, so this is 0, right, because the knob is all the way up there. So now let's increase this. Let's see what is the maximum variable voltage at AC I'm going to see. So if you can see my settings are at voltage at 0, at AC voltages. So the maximum that I'm getting is about 400. Why? It's supposed to give you 380 volts. Why am I getting 400? Because there is no load connected. Once you connect the load, it should maintain that 380 volts. And just to remind you, in South Asia, normally the voltage which is coming out from your PMTs, your transformers, is 440 volts. But in North America, that might be different. So that's why you're getting that variable. So once I have it on 50%, I should get around 200. Indeed, I'm getting 202 volts. All right, so let me just turn this off. So this is from line to line. From line to line, I can even switch this to move this over here. But what about line to phase? What is the maximum that I can get from line to phase? So I'm just going to simply move this over here. From line to phase to neutral, the maximum voltage I can get is around 220 volts. So still I'm getting 230 volts because, as I explained you before, so from line to line you get maximum 380 volts. From line to neutral, even in a variable mode, you will get the maximum voltage you can get is around 220 volts. Now the next step is going to be the fixed voltage now, which is this guy. This is where the fixed voltage is coming out. So move over here, and I'm going to do exactly the same thing. From line to line, I should get 380, a little bit over 380 volts without even moving the knob. So right now my knob is all the way counterclockwise, which is at 0. So it does not have any effect on this. Same thing when I do line to neutral, I should get 220, which is fixed. So at variable, the maximum you can get, the current that you can get out is about 3 amperes, and in fixed, the maximum current that you can get out is around 10 amperes. So that's the basic idea behind the LabVolt power supply that has 3 phases, fixed 3 phases. You can have variable DC supplies and things like that. So if you have any questions, leave it in a comment section, and don't forget to like and subscribe to my channel.